Hello everyone, today let's solve the problem number 125, valid palindrome. So what the question states here, a phrase is a palindrome if after converting all the uppercase letters into lowercase letters. First thing we have to keep in mind, a phrase is a palindrome if after converting all the uppercase letters into lowercase letters and removing all non-alphanumeric characters. These two things. Just keep in mind, we have to convert all the uppercase letters into lowercase letters and removing we have to remove all the non-alphanumeric characters. A phrase is palindrome if after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backward. Means a phrase should read the same forward and backward, each characters we are speaking of within the phrase, right? So alphanumeric characters include letters and numbers. They have strictly mentioned we have to remove the alphanumeric characters include letters and numbers. We have to we have to remove all non-alphanumeric characters, right? So alphanumeric characters include letters and numbers. Means it the phrase might contain only has to contain or might contain only letters and digits, right? So given a string s, we have to return true. So we have been given a string s here, you can clearly see, right? Here we have to return true if it is a palindrome. If it is a palindrome means they have clearly mentioned here, if it reads the a phrase is a palindrome if it reads the same forward and backward, right? Given a string s, we have to return true if it is a palindrome, or we have to return false, right? So two requirements or two conditions they have given here as we have to convert all the uppercase letters into the lowercase letters and we have to remove all the non-alphanumeric characters. Alphanumeric characters means it includes only letters and numbers they have given, right? So I hope the question is completely clear, right? So let's come to the first example here. So let's come to the first example here. They have wonderfully explained with the examples here. They have shown with the three examples here. So here you can clearly see we have a man, a plan, a canal, Panama, right? So a space after a we have space, man after this one we have comma. So this one again we have comma here, we have colon here, right? So except alphanumeric characters means characters and digits we have to remove everything. So first step here is we need to convert all the uppercase letters to lowercase letters, right? All the uppercase letter to lowercase in this, right? So first this one will convert all the uppercase to lowercase and we have to remove all the alphanumeric non-alphanumeric characters as well. Means comma, space also we need to remove, comma also we need to remove, and we need to remove this one colon as well. So after removing this one we get this word, this particular word, a man, a place, a canal, Panama. So if you read this one from the backward, then also it is same, a man, a place, a canal, Panama, right? That is why it is said to be palindrome and we need to return true in this case. We need to return true in this case. I hope first example is completely clear. Let's come to the second example here. Yes, we have race space a space car. So here all the letters are lowercase itself. So we don't have to worry about the first thing. And second thing here is we need to convert or we need to remove all the non-alphanumeric characters right here. So we need to remove space in this case. So race a car, we will get this one, but when we read this one from the backward, will not get race a car itself, right? RACA we will get right here in this case. So this is not same from reading backward. So this is not a palindrome. In that case, when it is not a palindrome, we have to return the boolean value false. So an empty an empty string is always considered as a palindrome, right? Just keep this in mind. We will be discussing the same in edge cases as well. So an empty string is always said to be this one, palindrome. In this case, we will return true. So S is an empty string. This one after removing non-alphanumeric characters. We have one space here. So after removing this one, we get empty string, and empty string is always said to be a palindrome, right? So since an empty string reads the same forward and backward, it is said to be palindrome. That's what they have given in the explanation. They have explained beautifully here. This is fine. So I hope all the three examples, whatever they have given, is completely clear as well. I hope the question is clear. I hope what we need to do is completely clear as well. First step, what we will do here, the first thing we'll do here is we will discuss the approach followed by the edge cases one by one, and then write the code and discuss the complexities for the code that we have written. First thing is, let's discuss the approach. So let's discuss the approach step by step here. So first thing here we need to discuss here is, so first thing we need to consider here is we are going with the 2 pointers here. So we will be going with the 2 pointers, or we are going with the 2 pointers here, right? So 2 pointer approach. So I have considered the same example, the first example that they have given in the question in this case, right? The first example that they have given in the question: a man, a plan, a kennel, Panama, right? So this one is true because we know the process string we have already saw. After removing this one, after removing the non-alphanumeric characters, as well as after converting all the letters to the lower case, we this reads the same from the backward and forward as well, right? Forward and backward. So the output is true in this case. The first example we have already discussed this one. Let's see the step-by-step execution right here. The first step here is, so we have considered the same example here, right? This one: a man, a plan, a kennel, Panama. So this one we have to convert, or we will be converting this one to the lower case, right? And we will remove the non-alphanumeric characters. So first step here is, while writing the code, what we'll do, we'll convert this one to the lower case, and we will remove all the non-alphanumeric characters. This is the first step. Simple, right? Let's move on with the second step. So here the process string is this one. Process string is this one. After removing the non-alphanumeric characters as well as converting all the letters to this one, lowercase, the process string is this one, right? So let's move on with the second step here. We will be making use of the 2 pointer approach, or 2 pointers. We have already discussed this one. So we will be making use of the 2 pointers here. So one is L and one is R. L at the start, and R at the end. So L, this will start from this one. This is L and this is R, right? L at the start and R at the end. We'll be making use of the 2 pointers here. First, what we will do, we will compare S of L and S of R, and then we will move inward if they match. Then we will move inward if they match. If they don't match, then we will return false. If they don't match, then we will, what we will do, we will return false, right? We have to continue until L is greater than or equal to R. If all the characters match, then we will return true. We have to continue until L is greater than or equal to R. This is important. This is important point. Just keep this in mind. So let's come to the process string here. First, what we will do, we will compare A with A here. This is fine. A equals to A. We are comparing right here. Next, we will compare M with M. This is fine. This is true. A with A again, true. N with N again, true. A with A again, true. P with P again here, true. L with L here, true. A with A here again, true. N with N here, true. A with A here, true. When we come to C, we have only individual character. In this case, if you see here, L is not equal to R, L is greater than R. So as L is greater than R, here what we will do, we will stop. L is greater than R. So this will be L. This will be considered L because A is equal to A in this case. Next, we will move L to here, right? So L is greater than R, then we will stop. So we don't have the next character at all. Then in this case, this is said to be palindrome, right? So here we can clearly see we will continue until L is greater than or equal to R. If all the characters match, then we will return true. So in this case, all other characters match. Here all the characters match and L is greater than R. So it is said to be palindrome, and in this case we will return true. In this case we will return true, right? Same goes with MAM as well here, right? So first L, if we consider L, so this one what we will do, first we will convert this one to lowercase letter and we will remove all the non-alphanumeric characters. characters. L, we will compare this one LR first. M is equal to M, and this one we will move L to the next one. Here L will be this one, but we don't have other character at all, right? So we don't have other character. L is greater than R here. We will stop. Simple example for the palindrome. We will return true. These two things you can consider. If L is equal to R as well, we will compare the same thing, right? I mean, we will return true itself, right? So let's come to this one. When L is equal to R, I'll just show you. So when L is equal to R, we will consider that one an edge case, right? So we will be speaking that one an edge case. So now we know this one. Accordingly, with the first example, why this is true, why we are returning Boolean value true in this case, we know, right? We have discussed this one clearly. Now we are familiar with the approach, right? So now we are familiar with the approach. So let's start discussing the edge cases. So the first edge case here is only special characters. We have special characters. First thing here is we need to convert this one to the lower case, right? So we don't have alphanumeric characters at all here. So we will remove all the special characters. I mean, we will remove all the non-alphanumeric characters. This becomes empty string. So when we remove space as well, this becomes this one. Empty string, right? Empty string is always considered palindrome. We have already discussed this one, right? So we will return true in this case. So let's move on with the second edge case here, single character string. So process string we got here is A. We have only A here. Process string we got A. Output will be true itself, right? This is a palindrome, single character string. Let's go with the third one here. We have 1 2 3 2 1. So process string here becomes, sorry, in this case I have written wrong. Here in this case, process string becomes 1 2 3 2 1 itself, right? 1 2 3 2 1 itself. This is true because if we read from the backward, this is same as the original one, right? Same as the original one. So it is set to be palindrome, and we have to return true in that case. So fourth one, let's come to the fourth edge case, string with spaces and punctuation. Previously we considered single character string and string with the numbers for the third one, right? Fourth one, we have to we have considered here as no X and Nixon, right? So here in this case, we have removed the special characters here. This one, single inverted comma I'm speaking of, right? And also we need to remove this one, spaces as well, and convert the capital letters to smaller. I mean, uppercase to lowercase, right? So here in this case, so after processing this one, process string is this one. We get no Exon Nixon. So if you read this one from the backward, so no XN Nixon. This is same as the original one, right? Here, this one I'm speaking of. So it is said to be true here in this case, right? So let's move on with the final edge case or non-palindromic case. Here we have hello. We have hello here in this case. So hello, for the hello, the process string is hello. Means after removing non-alphanumeric characters and after converting the this one uppercase to lowercase letters, we get hello itself. So output is false here. When we read from the backward, it is not same, right? It will be ole something, OLLEH. This is HELLO, right? So this is not same. Output is false. And you can observe one thing in the fourth edge case. I said so when this one L will be equal to R, here you can consider here this one and no Exon Nixon. So accordingly with the approach, we will go with the L first. This will be L and this will be R, right? So this will be L and this will be R in this case. First we will check this L is equal to R. Yes, it is. Next we will move L to O and we will decrement the R here. So O is equal to O, same thing. Next we'll consider for X, it is same. We'll consider for I, it is same. We'll consider for N, it is same. So here in this case, L is equal to R, right? So L is equal to R. We don't have the extra character. Means L is not greater than R. Then also it is set to be palindrome, and we will stop here and we have to return true in this case, right? So at that time, I said we will be discussing L equals R during the edge case, right? That's what. For this one, you have to you can consider this one, right? When L equals R. So these are the 5 edge cases that we need to keep in mind, right? I hope this is completely clear. The first edge case here is edge case was for this one, only special characters. The second edge case was for this one, single character string. The third edge case was for string with numbers. The fourth edge case was for string with punctuation, right? String with spaces and punctuation. And the fifth edge case here is this one, non-palindromic case, right? So these are the edge cases that we need to keep in mind. So now, as we are familiar with the approach as well as the edge cases, it will be easier to write the code. Let's start writing the code. So let's come to the coding part here. So what we'll do first, we have to initialize the 2 pointers. One is at the start and one is at the end. So I'll just go with here, and we have already discussed this one. L equals 0, and right at the end, nothing but I can just write here length of the s minus 1. So this one, length Java, right? So this is fine. The next step here is we have to skip the non-alpha numeric characters. So as we have considered left and right pointers, we have to skip non-alpha numeric characters from left as well as right. So for that one, we have to articulate the same thing in the form of code. So first thing, so while left less than right. So I'll just consider this one, simple while loop, because this has to be true. Left has to be less than right. So first here is, I'll just make use of while loop. We are just skipping non-alpha numeric letters, non-alpha numeric characters from left. So I can just write this one in this way. While L less than R here and not of character here dot is letter or digit. I'll just go with a digit here. S dot char at this one at 1. This is fine. We are just skipping here non-alpha numeric characters from left. So then we have to move to the next this one, return, right? So we have to increment the left pointer and we have to decrement the right pointer. We have already discussed this one. Same thing goes with the this one as well. Right pointer, I mean, we have to skip the non-alpha numeric characters as well, and we have to decrement the right pointer, right? So when we compare, so I'll just copy the same thing over here. This one, what change I have to do here? In this case, S of character, this one L, right? So this one left. This is fine. We are ignoring this one. This is R. This has to be R in this case. This is the only change, I think. We have to skip alphanumeric characters from right. So this is only change, I think. Yeah, this is fine. So we have to decrement the right. If both the letters matches, then we have to decrement the right pointer. We have already discussed this one, right? This is fine. So the next step here is, we have to compare the lowercase letters, right? So that's what we have to compare the lowercase letters. So in this case, I can just write here character to lowercase here of s dot, just make use of caret L. This one L, this should not be equal to character dot to lowercase. This one itself I'll copy until here. What do you say? I don't want to type this one again. Let me copy this one. Instead of L, I'll just make this one R, right? So here, what we are doing here in this case, basically we have to compare the lowercase letters, right? In this case, every time we compare this one, A, this has to be equal. In this case, if it is not equal, we have considered if it is not equal, then directly we can return false. So it has to be equal, because for this one, this what to be palindrome, every letter has to be equal, right? So if it is not equal in this case we have to we will directly return false. So I'll just write here return false in this case. So next, every step after comparing this one, I have already said this one. After comparing this one, we have to increment the left pointer and we have to decrement the right pointer, right? So we have to increment the left pointer and decrement the right pointer every step. So I can just write here in this way, right? Increment the left pointer and decrement the right pointer. This is fine. So the final step here is, if the loop completes without returning false, then it is said to be palindrome. If the loop completes without returning false, so here in this case, all the steps the loop returned true itself, right? So we have discussed this one during the approach by considering the same example. That is the reason I'm considering the same example here to show, right? So here in this case, if the loop completes without returning false, it is said to be palindrome. In this case, loop completed without returning false, right? That is the reason we have returned the boolean value true here in this case. So let's return true. Again, if the loop completes without returning false, it is said to be palindrome here. So that is the reason we are returning true here. This is it for the code. Let me hit the run button. So I hope this works. Wrong answer. Why? So what is the output we are getting? Output we are getting false. Expected true. Somewhere the condition we have written this one. Removing all alphanumeric, non-alphanumeric characters or the uppercase. That one we have done wrong, I think, somewhere. Let's. So I think here in the line number 7, we don't need this one, I think. What do you call semicolon? So while loop, same thing goes with the line number 9 as well. So let me see. Let me hit the run button. Let's see whether this works or not. So just give me a second. Yeah, now you can clearly see here the sample test cases are getting passed. So here for the while loop, I had directly given this one, what do you call semicolon. So that's why it was not working. So that's why we were getting wrong answer, right? So now the sample test cases are getting passed. Let me hit the submit button quickly. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct in this case, right? So let's quickly discuss the complexities for the code that we have written. So here in this case, the approach that we went with here is 2 pointers. We know that, right? So the approach that we went with here is, so what would be the time complexity here? The overall time complexity here would be big of n. Why it is big of n here? Because each character is processed at most once. Each character is processed at most once, right? So we are making use of the 2 pointers. One is left and one is right. So we are processing each character at most once. We know this one, right? So overall time complexity would be big of n in this case. So what will be the space complexity here? The overall space complexity would be big of 1. Why it is big of 1 here? Because we are making use of only few extra variables, right? So no additional data structures is required here. We are making only a few extra variables here in this case. You can clearly see lambda. So we are making use of only few extra variables here and no additional data structures are required. That is why the space complexity here is big of 1. So the time complexity here is big of n and the space complexity here is big of 1 for the code that we have written. I hope whatever the code that we have written is completely clear as well. For now, this is it. Thanks for watching, guys.